Hi, I'm Erika Heidi, Staff DevRel Engineer at 𝗬𝗏𝗀. In this short presentation, I will share 5 strategies to mitigate software supply chain risks in GitHub Actions. So the first thing you should do is inspect your repositories for insecure defaults and other bad practices. For instance, using pull request target with head code execution, or using long-lived personal access tokens with broad privileges, direct shell execution that can be manipulated by external actors, and also actions pinned by tag. These are some things that you should look for. I will talk a little bit more about each of these things. Another thing is unprotected main branch and unprotected release tags. It can be a little bit overwhelming, but the good news is that you can use Copilot agent in your repository directly and ask it for evaluate your GitHub Actions and find any potential vulnerabilities. That was the prompt I used, for instance, here. And it was very effective in detecting the issues. So this was a repo that I set up for testing, and I created intentionally a lot of insecure things and as a demo to demonstrate secret exfiltration. And so this has a vulnerable GitHub action workflow, and Copilot was very successful in detecting the issues. Pull request targets with code execution. So why that's an issue? Because when someone creates a pull request, then the code from the pull request is executed. And when you use pull request targets, this is executed in the context of the actual main branch and all the secrets and all the environment variables that are used in the actual builds in the main branch. So any variables that you have, any secrets that you have, can be exfiltrated depending on how you run your code in this workflow. And the Copilot detected the pull request targets with execution that runs go setup. So this is a method that was, this is the same method that was used for the initial Trivy exploitation. So they exploited the pull request targets that was using PAT with broad privileges. And another thing was secrets exposed to attacker-controlled binary. It's also critical. Write-capable token also give permission for writing the pull request is also high risk. And also, it also pointed out the actions pinned to a tag. So this is insecure because tags can be rewritten, and this was also used in the Trivy attack. The attackers were able to rewrite previous tags all to point to the same malicious commit. So if you were pinning your action by tag, you would pull the new code with malicious injected payloads. So yes, this workflow is definitely vulnerable. Ask Copilot to check your repo and see if it can find any vulnerabilities. So you should protect your branches, your main branch, especially in your tags, so they cannot be rewritten. This would prevent the malicious code to be released to other users, and it would contain propagation. And also, you should protect your main branch to prevent push directly to the main branch. And attackers can also use stolen PAT to inject directly on the main branch. So this is also very important. And is a setting that you need to change. So by default, you don't have this protection. So you need to go there in your repo settings and enable these protections. So the second tip important for minimizing your risk is minimizing your attack surface. So this is like one of the simplest practices. In theory, it's so simple. Just make sure you have a smaller attack surface so you have less entry points to be exploited. It's like a low-hanging fruit that you cannot ignore. you have to think about direct and transitive dependencies. So the dependencies of your dependencies are also a risk. Any weak link in the chain can be used as a foothold to obtain access. And even with a low privilege access, they can also try to escalate privilege. This is another type of exploitation. But once they get access, there's a lot they can do. So the main idea is not to remove functionality. So you don't want to remove things that you actually use, but to remove what you don't need, what doesn't need to be there in your runtime, especially because there are lots of dependencies in the runtime level, in the base OS level that you don't need. And one way to do that is by using minimal container images. So chain guard containers are very minimal. We build all packages from source, and that helps us keep the images always up to date and with all patches applied. So we are able to have, for instance, our Python image. The latest CVE count was 4 CVEs against like 579 for the default Python image you get from Docker Hub. So it's a significant change, and it's kind of a low-hanging fruit because you can just change the base images you use to build your runtimes and your GitHub Actions also, and use a smaller image with a small attack surface and less vulnerabilities. The third tip is pull from trusted sources. So I don't know if you know that, but 98% or more of malware is inserted during build and distribution time. So it bypasses regular review from maintainers. You don't see the actual exploit, the actual malicious code in the source code, in the repo, because it is introduced during CI/CD and injected directly into artifacts that are produced at build time and distributed to repositories everywhere. So public repos will download these artifacts that have been tampered with, and they are different actually from what is in the source code. So there is low visibility about what happens at build time usually. So one thing that happens a lot is a ghost release. Attackers are exploiting the gap between the verifiable source code and the build artifacts that we consume when we pull from these sources, the public registries. Public registries were built mostly to facilitate distribution of dependencies of libraries and facilitate collaboration, and they don't have a lot of security measures. Most of the public registries from language ecosystems don't have a lot of security measures to protect artifacts from tampering. So it was not a main concern when we started to share code this at this level. And at this volume. So now we are faced with registries that are public. They are also prone to be exploited. So attackers are shifting left and they are focusing on turning developer laptops and CI/CD pipelines into nodes for propagation, because that's where all the credentials and secrets are, and you can with these credentials, you can spread laterally and spread to other projects and other orgs even. So one way you can reduce a lot of this risk is by pulling from trusted sources your language dependencies using chain guard libraries. So we have libraries for Python, Java, and JavaScript ecosystems at the moment, and the way it works is we make sure that the build is safe, the build environment is a safe environment, tampering proof, and then you can pull these dependencies directly from our repos, and you will be avoiding more than 90% of the risks involved with build and distribution time attacks. So we don't execute any pre and post install scripts. So we don't build those libraries. You will only get versions that are safe to install. Another important practice is pin to digest. Even copilots pointed out that you should not use a tag to in your actions. You should pin to a digest. A digest is a unique hash pointing to a specific build of a container image or a GitHub action. So you are not pulling unknown code. You will always be pulling the same builds, the same codes that you were executing before. So of course, these will get stale with time. You need to update the digest when there's new versions released of the image or the GitHub actions, but it gives you time to update. You can use Digestabot. It's a tool that 𝗦𝗃𝗀𝗃 created, and it's free to use, open source, that you can use to keep your workflows and Docker files up to date. So whenever there is a new version of a container or a GitHub action, you will get pull requests with the updated digest. So it's very handy to keep your digest updated, and yeah, and pinning to a digest is the safest practice you can use regarding tagging containers and GitHub actions. So this is the action, and really you will define a workflow file, a YML file with a configuration, and yeah, then you will be able to do these updates automatically. And final advice I would say is to ban personal access tokens. Don't use long-lived tokens because they can be really dangerous. We usually forget about tokens, and a lot of people give a very long expiry time for the token and broad privileges, which can be really dangerous. That's what we saw happening with Trivy. They had an org-wide PAT that was exfiltrated, so attackers had full control over the whole org. They were able to delete and create repos, create releases, and do anything they wanted, basically. So using short-lived tokens is the best solution to make sure that you give only a limited privilege to a workflow run and for a limited amount of time. So even if the credential is exfiltrated, it will expire quickly, so you don't need to be so concerned about that. We have an app, also a GitHub app that you can install for free, call it Octo-STS, and implements this strategy using the same concepts behind Sigstore and cosign. So it will give you temporary credentials, and they will expire in a short period of time. So Octo-STS is actually the identity that we will open a pull request for you in your repo. And this is the app for you to find on GitHub. So a TLDR before we close. First, inspect your repository for insecure defaults and other bad practices. You can use copilots to help with that. Ask it to evaluate your GitHub actions and find vulnerabilities. Number two, minimize attack surface. So you remove a lot of the software that doesn't need to be there in your runtime. And then this means that you have less entry points for an attacker to exploit and less vulnerabilities. So the third one is pull from trusted sources. We are seeing an increase on NPM issues, incidents, and it's very important for us now to think about where we are pulling our open source software from. So pull from trusted sources. And the number 4 is pin by digest. Don't pin by tag because tags can be hijacked. So pin by digest and use Digestabot to keep them updated. And number 5, ban long-lived personal access tokens and use a short-lived tokens instead. You can use Octo-STS for that. And yes, that was all I had for this short presentation. I hope you stay safe and see you next time.